we're going to have to write this not as a script, but you would write it just in the same way. You would be in a different window.
New is probably alias.
Do you guys want to explain while I type?
Do you want to try Command N real quick?
What?
Command N is probably new file.
Okay.
No, it's
it
not.
doesn't
Don't worry
work.
about it.
Sorry, on my crappy computer. Do you guys want to explain while I type?
Yeah.
Okay. Okay. So the first thing we're trying to do right now is we're kind of fixing up this data set. So we're gonna take into account like what he mentioned earlier about the food. So when we want to put it in the form that we had before, we don't want to have any food names in there. We want it to be all like values. And also this one would be this price.serving column. This is actually like your B column. So we want to isolate that from your A matrix. Yeah. So I'm just going to...
So is it better to do this kind of cleaning up in R, or is it better to do it first in Excel and create, say, two matrices, a constraint matrix A without names and a vector B matrix?
Both are valid.
Both are valid.
The reason you would do this is so you don't have lots of data files floating around. It's all contained in one data file. The reason you do that is it makes your R code look simpler. So
Okay.
it's kind of a trade-off of simpler data versus simpler code.
And some of these things like drop equals false, at this point you just don't really worry about it.
Question?
Yeah, so are you doing data food is null, data index is null, just get rid of those columns when you consider it? Or
Ye-
why are you saying it's null?
We're just trying to get rid of the index columns and the food columns.
Yeah.
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 Yep.
And so she's data $food before she did that assignment to null rather, would have pointed to that list of string names, but when she assigns it to null, that sort of overwrites that string, so that string is gone. And it's not treated as part of the data anymore.
And you're doing data because you've called this file data.
Yeah.
Yeah.
Up here, she said data.
Right,
she said
exactly.
view.csv.
Right.
Are any of you in Comp Sci 136 this semester? Yeah, this arrow is not the arrow you're used to from C. So, FYI, they do not get that confused. This is just an equal sign.
Okay. Yeah, so up until here, we've already set everything up. So the linear program it's pretty much ready. And does anybody have any? Okay. So cost as matrix. So you can. That's like a function where you can take the data here, and you can turn it into a matrix. And it's like basically, you're taking just the cost column. Over here.
And it's because you know that there's a column labeled cost column,
Yep.
right?
And you know
Okay.
that because that's like column number 12, and this corresponds to column number 12 over here. Yep. And then boundaries, we loaded that CSV. And now for our B, what we did was, so boundaries looks like this. So we just made, we concatenated the min column with the max column. And then we named our new LP, res, and we just put in all of the arguments as such, like before. And here, TA, that's transpose matrix A, and we do that just because, like with linear algebra, sometimes you want.
What rbind does is if you have two columns, it puts them together to make you a matrix.
Ah, yeah.
Yeah. So if you had a column 1, 3, and you had a column 2, 4, and you would put them together, you'd have the matrix 1, 2 on the first row, 3, 4 on the second row. Yeah?
So why combine two transposes with the same one together, if that's what's happening?
Oh, for this one?
Yeah.
For this one, it's okay because you want to sort of manipulate it such that it's in like the form that here like
So-
You're transposing it, but why are the two of them?
okay, so we did two of them because I think it's because I don't remember. I think it's because like one corresponds to the minimum, one corresponds to the maximum. Okay.
But are you taking the transposes because the matrix is not given in the form you want?
Yeah, because our matrix, like in its raw form, is like that, and for some of them we don't want it to be like that. We want it to be like transposed.
Okay, so just because of the linear programming problem we're doing,
Yeah.
the information was not given to us in the way we want. And this frequently happens is there's not a universal standard as to how things are presented. And because of that, you often get things in a different form than you want, and you have to do a little bit of work, cleaning the data, formatting it as you want. Hopefully you can begin to understand why we now have what's called the canonical linear programming problem. That this makes it much easier. The data is now known to be given in a certain form. Whereas here, this is very similar. I think we mentioned a Mars mission which led to a $25 million crater on Mars because one of the subsystems thought the measurement was coming in the English system and miscalculated the thrust needed for landing.
Okay, so right now you have everything already, and you can just call. But what we're gonna do is we're going to, like, if you just call the solution right now, it's going to be pretty like ugly. It's hard to interpret what that means. So now we're just gonna get it into a format that is more easy to interpret.
And solution is just the variable where she put the output from the LP solver. It's not something special.
Yeah, and this is like making corresponding these to their corresponding food names. And amount here, we're doing that so that we don't see. We're taking out all the zero values, so we only see the food names that you want, that are non-zero. Yeah.
So, if people want, we do have some funds for meals for this class.
Yeah. So to this particular diet problem, this would be your solution. And yeah.
Do you guys like potatoes?
Yeah.
Good.
Especially with air-popped popcorn.
It's like not dissimilar to my actual diet.
All right, we'll get you a few more columns. Do you want to go up and just explain very briefly the different lines you have and just walk us through?
Yeah, okay.
So we start off with data, so we read into the data file, the file name.
Yep.
View data allows us to see in the top part of the screen up here what the matrix looks like.
Mm-hmm.
Cost column to 12, that's going to be for our objective function?
Yeah.
Okay.
That's for object function.
And
It's cost
just sort of
column,
taking a step back, what she's trying to do with this code, she knows the arguments she needs to put into this function LP, and she's just building each of those from this larger CSV file, just taking a step back, that's what's going on here.
Right.
So most of this is just data manipulation.
Yeah. Like you could have saved a lot of these steps if you just pruned it in Excel beforehand. So actually don't have to.
Right, and
Follow
so
this.
you absolutely have that option of if you have a data set like this, you can use Excel, clean it up in Excel, and then save it, and then have it in a much nicer format for R. Or if you're comfortable with R, you can clean it in R. Either way is fine. All right, so now what is the data $ food to null? That's assigning all of those labels to 0,
Yep.
to empty.
To null.
My question is, what's the .csv?
That's
That's a
format.
file format. So in Excel, I can't say.
Comma separated values.
Yeah.
Values.
It's
In
a way of
Excel.
representing a table in
Yep.
plain text, where commas separate elements in a row, and then a new line will put you on
Okay.
the new row.
Sometimes if you have a data file and you try to open it up with Excel, it asks you how do you want to delimit the data. You can do it with commas, you can do it with semicolons, you can do it with spaces, you can do it with tabs.
If you could input this in matrix form, you can comment anyway, it makes sense just to have the .csv.
Yeah, and any spreadsheet software will let you output stuff in CSV, and a lot of data just comes in CSV form also. Yeah. And it's called CSV, but it's not necessarily commas. It can be any delimiter. And I know
Right.
the CSV function has an argument delimiter and an argument new line. So you can just tell it, if you have some file, you can just tell it to treat it as a CSV, treating some characters the delimiter and some characters the new line. So it's pretty general and pretty useful for stuff like that.
Alright, so now when you set these to null, is it essentially forgetting about those columns?
Exactly.
Yeah.
But does that change then the numbering of the other columns? As to what's now column 1, column 2, column 3, if you set something to null?
I'm not familiar enough with R to
Actually-
know the answer to that.
Because you named it wrong, row names before you said it's null, you can later call row names to identify what values you have with like, when in the bottom, when you cleaned up the, like when you got rid of all the zeros and stuff, you like, I don't remember what the function was, but you somehow called like row names again to like label what the
Yeah.
values each were, right there.
Yep.
So because you saved row names data food before you said data food.
We did,
null, it
yeah.
like makes it okay.
Yeah.
But once you've set that to null, does that change the numbering of the columns? As to now what's the 12th column? That's something we will check on.
Yeah, we'll check that. I'm not sure.
But you've got to be very careful when you do something like this. What if this does change how the columns are numbered once you've set something to null? You could accidentally be using the wrong objective function, and you may end up eating, oh, I don't know, raw potatoes with raw carrots and popcorn.
Also, another, maybe this seems like it's so much easier to do in Excel, but if you have like some sort of systematic thing you're checking, or if you have some systematic error that you're trying to replace, you want to code it because you don't, say you have thousands of entries in your Excel file, you don't want to manually change each one. There are reasons why you would want to do it more automated like this. Maybe it's not so clear in this example, but
There's also a limit to how big of a file Excel can work with.
Yeah. And this will almost always be faster because Excel has to keep track of a lot more than just the data because you've got
Right.
formatting issues and their file
Right.
format's more
Can you walk us through now what does this line do?
Values.
yeah, you got a question?
Yeah, so like your B vector, so that just represents that like some things we have to have a certain amount of, and other things we can only have so much of. Like I don't know, sorry, can you just explain that to?
Let's go down line. So what is the A? So we're assigning to A as.matrix. What does as.matrix mean?
Like as a matrix, so you're taking this Excel,
Okay.
this table over here, and you're kind of like converting it into a matrix form.
Okay.
And right here, this little, I'm too short for this. Can you move it to I'm gonna sit, this brutal right here. That's just is notation that you're really only talking about the columns. You're going by column, not by row. So it's a matrix, so it really has like an A, comma B, row and column. But that you'll use this a lot in your other stat classes too. This is how you talk about just the columns. If you wanted just the rows, you'd have like row and then a comma ending the square bracket. That's
It's like list slicing in Python, if anyone knows Python.
That's actually like,
colon.
you'll use that all the time in your other stat classes too.
Yeah, and I guess like it does retain the old column.
It does retain the own
It
column
does,
number.
yes.
Okay.
It retains it. Yeah.
All right. So then next is we have boundaries.
Yeah. Next we have boundaries, which we just we read it in
And so what is the boundaries?
constraints.
Oh, okay.
Yeah, our
And
constraint
okay, you're calling the
matrix.
constraints boundaries.
Yeah. Yeah.
Okay.
Yep. And then so your boundaries looks like this, and then with B, what we did was we made a vector like this. So we just concatenated all the min values with all the max values. Yep.
And then keeping track of which ones are mins, which ones are maxes.
Yeah.
All right. And then what does RES stand for? You're saving it as?
We're just RES, like results. And
Okay.
LP.
Okay. RES is just
Yeah.
what you're naming the results. Okay.
Yeah, you can name it. You can name it anything.
Right.
Yeah.
And then you're calling the linear, and then LP means you're calling the linear programming function.
Yep. And then here again, this is because we actually have.
Because you have mins and
max.
maxes.
Yeah.
Question?
But why? So I guess that makes sense. Like that's why we have the matrix twice. But like, why are there maxes? Like why?
why are there maxes and mins, you mean?
Have you ever seen a laboratory mouse get a workout where they inject the mouse with things? Let's see what happens if we give this mouse, 10,000 times the amount of caffeine a normal human being gets in a day. Oh, mouse is dead.
Yeah, like for this, yeah, you don't want to, you have a maximum diet, I'm sure. Like you don't want, and also actually for this one, you didn't need to have it in 2 columns. A lot of manipulations that we did here was just because it was in 2 columns, so we had to go through that extra effort to make it into a form where it's like all 1 column in a matrix. Yeah, actually, like the TAT here, like everything, you could just have in 1 column and it'll make your life a lot easier. But it's also a little like, but this is a lot clearer as to what we're trying to get at, right? Yeah. Yeah. Are we almost out of time?
We are, it doesn't really make sense to start.
Okay, so that's.
So, next time we'll go through doing a similar thing to this in Python, and then on Friday we'll talk about some more general software development stuff that might help for final projects. We're going to talk about package management in Python, so how you manage different software that you want to use, and also version control, which is a super useful tool for working in a group with lots of people and keeping track of changes and being able to revert and see who contributes what and have a sort of